Hello class, this is the continuation of angles and angle measures, part 2. Angle addition postulate. This is again a postulate, so that means it's a rule given without proof. You're just going to have to accept it for the way it is. What it's also saying is two adjacent angles, when added together, will equal a larger angle. So in the example just below, angle RSP and angle PST can add up together to be angle RST. Please note, if they do not share a side in common, this would not be allowed. For instance, if angle S, not angle S, if ray SP was not a side for both angles RSP and angle PST, it would not be able to have the angle addition postulate apply. So for instance, if measure of angle RSP is 30 degrees and measure of angle PST is 20 degrees, that means the measure of angle RST is 50 degrees, 30 plus 20. Using that idea, let's do this problem. Given that the measure of angle RST is 80 degrees, find the measure of angle PST and the measure of angle RSP. Just a quick note, you can rewrite this in that other form. This form right here, angle RSP, instead of writing out the full word angle, it's just actually easier for me on my computer when I'm in PowerPoint to just write out the word angle instead of trying to insert the symbol. In this example, what I see is two adjacent angles, and right away what I'm thinking is that maybe these two adjacent angles add up to be a larger angle. But I see that this angle RSP is labeled as 3x minus 5. I see that angle PST is labeled as 2x plus 10. I need to find x. Well, find the measure of angle PST and the measure of angle RSP. I don't even care about x in the long run, but if I know x, I can answer those just by plugging it in. My thought is, hey, we just talked about angle addition, so what if I added this angle to equal the large angle? Well, I need to know what the measure of angle RST is. Luckily, it says it right here. This is angle addition postulate written out in in equation form for this specific example. Now I'm just going to plug in everything I know. I know that measure of angle RST is 80 degrees, so I'm going to put 80 in for that whole thing. For measure of angle RSP, I'm going to put that 3x minus 5. And for measure of angle PST, I'm going to be putting in 2x plus 10. Yes, the degrees are all required. However, with them all being in place, they can just kind of drop off. We can ignore units because they are all the same. And when you add two of the same types of units together, you will not change the unit. Now that they are dropped, I look at this, those parentheses on the right side really aren't needed because there's not anything multiplying into the parentheses. So let's get rid of them. Now that it doesn't have the parentheses, now it's time to just add like terms on the right side. Now that the like terms have been added, let's subtract 5 from both sides because I'm trying to solve for x. And last but not least, trying to solve for x, I need to do the opposite of multiplying by 5, so I divide by 5. I get x equals 15. But remember, I'm looking for the measure of angle PST and the measure of angle RSP. I don't care what x really is. So at this point, knowing x equals 15 is important, but now I need to plug it into both of my measures of my angles. For measure of angle RSP, that's what I will get when I plug in 15 for x. Now I just have to do order of operations. 3 times 15 minus 5. When I simplify, I get 40 degrees. Remember, box your answer when you are done. For measure of angle RSP, I'm doing 2 times 15 plus 10. Coincidentally, I get measure of angle RSP to be the same measure, 40 degrees. I did this intentionally, so that way I could talk about another thing right away. These two angles, angle PST and angle RSP, are what we call congruent. They are congruent because they have the same measure. If I can write measure of angle, measure of angle RSP equals measure of angle PST, that means those two angles have the same measure. That also means those two angles are the same size and shape, which means we can call them the word congruent. So angle PST is congruent to angle RSP. Written as such, angle RSP is congruent to angle PST. That symbol right there is congruent. It's for shapes. It's the equal sign of shapes. Also, another thing that we could say is ray SP is, in fact, an angle bisector because it divides angle RST into two congruent angles. So ray SP is an angle bisector because it divides an angle into two congruent angles. This is what I just talked about. When we denote that something's congruent in a drawing, especially for angles, there's one way we do this. there's one main way that we do this. In this case, it looks like angle A and angle B are congruent, although I cannot assume that until it's marked or unless I'm told. This is one way to signify that angle A and angle B are congruent. If you see that drawn in and they're the same color, your book sometimes likes to trick you with different colors. But if they're the same color, that means they're congruent. Whether or not it's directly said, if it's in the drawing, that means it's congruent. If, in the same drawing, I also had angle C and angle D being congruent, I would draw, instead of one of those arcs, I would draw two next to each other. So this tells me that angle C and angle D are congruent, and angle A and angle B are congruent. However, I cannot tell you anything about angle B and angle C. By the drawing, it looks like they're not congruent, but drawings can be deceiving. The other way I've seen this done is they draw one arc for each angle, and then they again put the number of tallies just like segments for if it's congruent or not. So one tally for A and B means angle A and angle B are congruent. Two tallies for angle C and angle D means angle C and angle D are congruent. I cannot say anything about angle B and angle C, nor can I say anything about angle B and angle D. Example 3, it says ray AB bisects angle CAD. At this point in the problem, I would stop and draw a picture, whether or not I read the rest. This is what I would draw. Angle CAB and angles BAD are congruent because ray AB is a bisector. I also drew angle CAD. Now, I did look a little bit ahead. I saw 54 degrees. However, I realized later that it's not for the right one. If I know both of those are congruent, this should be pretty straightforward. The next part says the measure of angle BAD is 54 degrees. When I write it right there, it's going to be only for the angle that it contains. So I don't have to make any special denotation that angle BAD is 54 degrees. If it happened to be measure of angle CAD, though, I'd have to make a line or some sort of way to signify that it was both together. At this point, if I know that those two angles are congruent, I can right away say something about angle CAB. They have to be congruent because it's a bisector. So if they're congruent, the measure are the same. So measure of angle CAB has to be 54 degrees. Might as well write that in my diagram. And using the angle addition postulate, that's two smaller angles next to each other. I'm going to add them together to get the larger angle. Measure of angle CAD is going to be 54 plus 54, which is 108. And when I read the rest of the problem and I see what they're asking me, I realize that I actually did what I was supposed to. Box up my answer, and I am done with this problem. Yes, look at my drawing. CAD is definitely not obtuse, but 108 degrees is definitely an obtuse angle. It's just a drawing to help me out, so that way I can get an idea of what's going on, even if the numbers are incorrect. At this point, you should be able to identify angles. That's the previous video. You should be able to use a protractor. And last but not least, you should know bisectors and what congruent means and how to label it, especially for angles. And you should be able to use the angle addition postulate.